Welcome to Homework Lib.
Hi, so over here we're given the value for K for this reaction at 361 Kelvin, and we're told that we have the following concentrations of these compounds, but we're going to reduce the volume to one half of the original. So B2 is going to be equal to one half of the original volume. That means that the new concentrations are going to be twice the original concentrations. So when the volume is equal to 8.6 liters, the concentration of these compounds is going to be 0.129 times 2, which is 0.258. Next up for CO, the concentration would be 0.532 molar, and this would be equal to the concentration of Br2 that we're going to have. Thus, we can calculate the value for Q, which for this reaction is going to be equal to concentration of carbon monoxide times concentration of bromine gas divided by the concentration of CoBr2 of this brominated product, which is going to yield equal to 1.097. So, in this case, since the value for Q is larger than the equilibrium constant, that means that the equilibrium should be shifted towards reagents, or to the left on this reaction. And now we want to calculate the new equilibrium concentrations that result when the equilibrium mixture is transferred to this volume. So now, since the reaction should be going towards the left, what we're going to consider is going to be the inverse reaction, CO plus Br2, which is going to produce CO Br2. And the equilibrium constant for this new equilibrium would be equal to 1 over the original value for K. Now, for us, over here, we're going to get 0.532, 0.532, and 0.258 as the initial concentrations on our ice table. All of this is going to be given in molarity. A fraction of X is going to be transformed into the product over here. So at equilibrium, we would get 0.532 minus X, 0.532 minus X, and 0.258 plus X. The new equilibrium constant would be equal to 1 over 0.546, which is 1.83150. And this new equilibrium would be equal to the concentration of CoBr2 divided by the concentration of CO times the concentration of Br2. Thus, we're going to end up with 0.258 plus X divided by 0.532 minus X squared. As you can see, this is going to be a quadratic expression which we can rearrange as 0.532 minus X squared times the equilibrium constant minus 0.258 minus X equal to 0. And solving this quadratic, we're going to find that the value for X, X1 and X2 are going to be 1.51, 624, which we can already discard because that would generate a negative value at the equilibrium over here. So this is going to be an unphysical solution. And the correct result would be the other solution for this quadratic, which is 0.093, 7553, taking all of the significant digits. So now in this case, since all of the quantities that are given to us are up to three significant digits, our result should be also up to three significant digits. So we can approximate this as 0.0937. So now our equilibrium concentrations are going to be for COBr2, this was 0.258 plus X, which is going to be 0.3517 molar, which runs up as 0.352 molar concentration. And for the concentration of carbon monoxide, which is going to be equal to the concentration of Br2, this was equal to 0.532 minus X, which is 0.4383 molar, which is going to round up as 0.438 molar concentration. Here I'm rounding up to three significant digits because those are the ones available on all of the quantities provided in the problem. If you want, you can take all of the significant digits through your calculations in the case that that is required of you for this course. But in general, you're asked to put the appropriate amount given the values provided. So with that, it would be all. Thank you very much and have a good one.